Okay, that was odd. So, here are the square roots and the squares, they cancel each other out. So basically the square roots cancel out each other. And we're left with y minus 3 squared equals x squared plus y plus 3 squared. All right, now we want to expand this square, okay? Expand this binomial squared. So remember, a plus b squared is a squared plus 2ab plus b squared. I'll put that in class as well. So here it's going to be y squared, and then y times negative 3 is negative 3y times 2 is negative 6y, and then negative 3 squared is positive 9 equals x squared. Do the same thing over here. So y squared is y squared. Y times 3 is 3y times 2 is 6y plus 3 squared is 9. All right, now we can cancel out. Let's move things to one side. Let's get all the y's to the left. If we do that, we're going to subtract y squared. Hey, cancels out. Let's subtract 9 as well while we're at it. Hey, it cancels out. And look at this. We're going to subtract the 6y as well. These cancel out. These do not cancel out. Negative 6y minus 6y is negative 12y equals x squared. Now, we would divide both sides by negative 12. And there we go. Our answer is y equals 1 over negative 12 x squared. If you're wondering where the 1 came from, there's an invisible 1 coefficient for the x squared. Okay, if you don't see a coefficient, there's an invisible 1. And that's it. Ta-da! That's the equation. All right, so let's look at the next one. It says identify the focus, directrix, and axis of symmetry of the parabola graph. So graph it. All right, so the first thing that we want to do, here we have negative 12y equals x squared. So you want to keep in mind which variable is being squared. Notice for this example, we have the x squared. So that's the regular parabola. Okay, that's the one that opens up or down. Okay, up or down. And then here, notice for this one, we have the y is squared. So that's the one that's going to be opening sideways. Okay. So just keep that in mind. And when you think about it, if it opens up or down, your focus is going to be here. It's going to be something like 0, p, and then your directrix is going to be y equals p, or negative p. And if it's horizontal like this one, so if you have y squared, it's going to be, the focus is going to be p, 0, and the directrix is going to be y equals negative p. Sorry, x equals negative p. So y squared, x equals x squared, y equals. Okay. So let's look at this one. First thing we want to do is rewrite it in standard form, which is y equals 1 over 4p x squared. So you get the y by itself, divide both sides by negative 12. Hey, that looks like the one we just did. Oops, sorry. My bad. So y equals negative 1 over negative 12 x squared. Okay, now we want to find p. So it looks like this. We want to notice that we want to set this equal to this. So let's put that over here. 1 over negative 12 equals 1 over 4p. Butterfly. Okay, or cross multiply. So 4p times 1 is 4p, and then negative 12 times 1 is negative 12. Divide by 4, and we get p equals negative 3. Ta-da! And imagine that we didn't see this answer already. It's going to be just like the first one. Why isn't it focusing? There we go. All right, so that's our P. So identify the focus. Focus is 0, comma, negative 3. All right. Remember, if it's y equals, the P is going to be on the y. If it's y equals, it's going to be, the P is going to be on the y for the focus. And the directrix, when it's y equals, the directrix is also y equals. And negative p, so negative, our p was negative 3. So you get y equals positive 3. And our axis of symmetry is x equals 0, that's it. And we'll look at one where the vertex is not at 0, 0, but that's later. Okay, now we're going to make a table. IKEA time. Let's go to IKEA. Make an XY table. Boom, 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 boom. All right. Vertex is 0, 0. And it's going to be 0, 0 for these first few problems. I'll let you know when it's not. When we're adding or subtracting something, that's when it's not going to be. Okay. So here we're just going to choose for the x's. Since we're using x squared, we're going to choose x values. So negative 1, negative 2, 1, and 2. Okay, so if you plug those in to the original problem right here, we get 1 squared is 1 times negative 112 is negative 112. Okay, and calculate that. I'm doing this all in my head. Just kidding, I'm using a calculator. You get 0.083. So negative 0.08. Okay, and 2, plug in 2, you get 2 squared is 4. And then 4 and 12 simplify, so you get negative 1/3. And that one becomes negative 0.3, repeating. And since it's symmetrical, this is going to be the same as this, negative 0.08. And this is going to be the same as this, negative 0.3, repeating. All right, so let's graph it. Our smallest y is very tiny, so you don't need to go too far. All right, so let's put 1, 2, 1, and 2, 1, 2, 3. It's not needed. Actually, yeah, let's make it a little bit smaller so that instead of scaling, like going by 2s, let's go by 0.1. So negative 0.1, negative 0.2, negative 0.3, negative 0.4, and this is just going to be 1, 2, negative 1, negative 2. All right, sorry. So we scaled it smaller, right? So we have 0, 0. Ta-dum. We have negative 1, comma, negative 0.08. So that's going to be close to the negative 0.1. And we have negative 2, comma, negative 0.3. All right, and this looks like a regular sized parabola. 1, comma, negative 0.08. 2 comma negative 0.3. It looks like it because we're actually zooming in. Okay, so if you use Desmos, it'll look really tiny. It'll look different. Okay, it's going to be really wide. Alright, and that's it. Do we have to show the focus in Directrix? I hope not, I didn't leave space. Oh well. Well, it looks like that. Alright, well that's it. Now let's look at 3. We have 8y squared minus x equals 0. Again, we want to get the variable that doesn't have the squared by itself. So we want to get the x by itself. And here we're going to add x to both sides. Those cancel out. 8y squared equals x. Yeah. Okay. So now let's find our p. So here notice that we want to set these equal to each other. So we have 8 equals 1 over 4p. Let's do it. So 8 equals 1 over 4p. If you want to put the 8 over 1, you can. Do you need to? No. So here, cross multiply again, or just multiply both sides by 4p. So 4p times 8 is 32p equals 1. Divide both sides by 32. And we get a tiny p. P equals 1 over 32. Okay. So our focus. Okay, remember before when it's y equals, the focus is going to be 0 comma p and the y coordinate. When it's x equals, the p is going to be in the x coordinate for the focus. Okay, so keep that in mind. So here our focus is 1 over 32 comma 0. Ta-da! And our directrix is, when it's x equals, our directrix is x equals. When it's y equals, our directrix is y equals. So x equals negative p, so negative 1 over 32. That's it. Axis of symmetry is y equals 0. Make a table. Let's make a table. IKEA time. X, Y. Okay, now this time, since we have x equals y squared, we're going to be putting numbers in for the y. Okay, so let's put 0, 0, since it's our vertex again. And we're going to choose the y values this time. Okay, so I'm going to choose -1, -2, 1, and 2. Now, be careful, because they're going to get really big numbers. Okay, so you plug that in to our formula. Oh, sorry, there you go. Let's plug that into the formula. So 1 squared is 1 times 8 is 8. Hey, that's great. All right. And 2 squared is 4 times 8 is 32. Hey, that's too much. And let's try -1. Is this symmetrical too? Let's find out. -1 squared is +1 times 8 is also 8. Hey, that's great. And then -2 squared is +4 times 8 is +32. And there you go. It's symmetrical. All right, but it's symmetrical sideways. So it's going to be opening up to the right. Okay, and how do you know it's to the right? Because it's going to be opening up to where the focus is. The focus is positive, so it's going to be opening up that way. Okay, so let's do that. And my y's, I'm just using 1 and 2. -1, and -2. And let's scoot the paper up. And for the x's, that's where it's going to get pretty big. All right, so it goes all the way to 32. Hey, let's go. Let's scale it. 2, 3, 4, 5, 6, 7, 8. Yeah, okay. Let's scale by 4. Why not? 4, 8, 12, 16, 20, 24, 28, 32. All right. So 0, 0, boom. And then we have 8, comma 32. Sorry, 8, comma -1. We also have 8, comma 1. Remember algebra 1? This is not a function. Okay. And then here we have 32, comma -2. And 32, comma 2. And that's our... It looks kind of like Groot, doesn't it? I am Groot. There you go. It's a parabola that opens sideways.